It is hard to believe this is a dam that America built over 90 years ago. Initially, to save construction materials, engineers chose the Colorado River next to the Black Canyon mountain range. Because the gap here is very narrow, they only needed to use half the materials to build a dam. However, what he did not expect was that the flow of the Colorado River is very strong. This caused the newly built dam to bend and the concrete inside to crack. Therefore, the engineer decided to change the dam to an arch shape and fill the interior with steel reinforcement. As powerful water pressure continuously impacted the arch dam, it gradually deformed. Although the concrete did not crack, the arch dam had a low center of gravity and lacked stability. When the load reached its limit, it would cause the arch dam to collapse. Therefore, the engineer increased the base area of the dam to overcome tensile stress and stability problems. Now, the dam will face another problem. The higher the dam is built, the greater its water storage capacity. This causes the pressure that the dam bears to continuously increase. Therefore, based on local rainfall, the engineer designed the dam height to be 726 feet, which is equivalent to 221 meters. After the dam design plan was decided, construction work began. The next thing to do was extremely difficult. Engineers needed to find a way to tame the fierce Colorado River before construction could proceed. However, draining the river water without affecting the flow was a difficult problem. The engineer thought for a long time and came up with a solution. He dug diversion tunnels on both sides of the river. Then he used sandbags to build a temporary cofferdam and pumped the water dry in the middle. This way, the flow could be diverted without affecting the river. The idea was great, but how to implement it? To facilitate digging the diversion tunnels, the engineer designed a special construction machine. He placed 2 rows of scaffolding behind the truck so that it could accommodate 30 people on top. These people used drill bits to drill holes in the rock and place explosives. After the explosives were installed, the truck pulled the scaffolding and workers quickly moved to a safe location to blast. Next, they used excavators to clear the debris and rubble. When the tunnel entrance was blasted open to prevent collapse, they needed to install a large amount of steel-reinforced concrete inside. Therefore, the engineer laid tracks on both sides of the tunnel. He used cranes to haul concrete and steel reinforcement to speed up construction. However, workers encountered difficulties when pouring concrete in the tunnel. Because the viscosity of the concrete was insufficient, it easily fell off the walls. Therefore, the engineer found an arched hydraulic form machine. This way, workers could easily complete the concrete pouring work at the top, as blasting, clearing, and pouring were repeated many times. Workers took 18 months to dig through the 4 diversion tunnels on both sides. Next, the engineer piled up the rock debris that trucks had previously cleared in the middle of the river to build a temporary cofferdam. This way, the river was successfully diverted. Now construction of the dam could begin. When the engineer was constructing according to the previous design plan, he discovered that the rock on both sides of the riverbed was very fragile. It could not support the dam at all. Therefore, he had workers drill holes in the rock walls and place explosives. He used blasting to clear the loose rock on the sidewalls. He also blasted openings in the mountains on both sides. At the same time, the dry riverbed could not bear the weight of the dam. The engineer had workers dig down 300 feet, which is equivalent to 91 meters. After reaching the hard bedrock, large-scale concrete pouring operations could begin. Initially, workers made forms from wood and then poured concrete into them. In order to transport concrete to the riverbed bottom more quickly, the engineer invented a dumping device. They just needed to use cranes to lower huge iron buckets containing concrete to the riverbed bottom. Then, workers pulled ropes to open the bottom switch. As the dam took shape, workers removed the wooden forms and discovered a new problem. Cement combined with water generates heat, causing the material to expand. This caused thermal cracks to appear on the dam's surface. Therefore, the engineer cleverly divided the entire dam into many blocks. Then, each mold was about 15 by 15 meters in size. Many steel pipes were also embedded in these concrete blocks. They were used to transport cold water to control the dam temperature. Now the dam has been perfectly connected to the canyon on both sides. The pressure it bears will also be distributed to the canyon on both sides. However, just when they removed the temporary cofferdam for testing, an accident occurred. The dam directly collapsed. After the incident, the engineer discovered that water flowing under the dam would generate enormous uplift force. This caused cracks to appear in the dam and then collapse. To reduce uplift force, he installed many drainage pipes below the dam. He guided the water flow to drain out from downstream. After solving various difficulties, the dam was finally completed. Next came the most critical part, building the power generation facilities. The engineer first built a U-shaped power plant downstream. He installed 17 large turbines and generators inside. Because these machines were too large, he had to figure out a way to transport them to the power plant at the bottom of the dam. Because tower cranes could not complete this task at all. Therefore, the engineer erected multiple cable installations in the canyon. Then, he used pulleys to transport the power generation equipment to the rail cars outside the power plant. Then, trains transported them to different areas for installation. These turbines have many blades, which are wrapped by pipes. When water enters the pipes, it pushes the blades to make the wheel rotate. A generator is connected below the turbine. The rotating turbine drives the generator to produce electricity. These processes seem simple, but in reality, directing water into the turbine is not easy. The engineer had to use explosives to dig a tunnel. He used conveyor belts and other equipment to dig and clear the dirt and rocks. After the tunnel was dug, he reinforced it with concrete. Then, water could be directed into the turbine pipes. However, an accident occurred again. High-speed flowing water generated enormous impact force that washed away the concrete in the tunnel. The engineer had to replace the concrete with steel pipes. He first bent steel plates and then welded them together. After filling the entire tunnel, he still needed to build a special water intake at the pipe entrance. Because traditional drain-style water intakes are easily blocked by debris underwater. Therefore, the engineers specially designed an intake tower with gates. At that time, German spies planned to destroy the dam. They wanted to blow up the intake tower, so debris would go through the pipes into the turbine. This plan was ultimately not implemented. But even if they really blew up one intake tower, it would only destroy one turbine. It would not cause all the turbines to stop operating. Now the power generation facilities are complete. Next, they had to figure out how to transmit the electricity out. Because the distance between the power plant and the ground is about 1,000 feet in height, the power lines could easily touch the rock walls on both sides. Therefore, the engineer built all the power transmission towers at an angle. This way, it could create distance between the power lines and the rock walls. When the dam construction was completed, the engineer discovered that when local rainfall increased, the water level would exceed the dam. This made it easy for the power plant below to be flooded and destroyed by overflowing water. Therefore, he built a spillway on both sides of the dam. Whenever the water level is still 25 feet from the dam height, it will flow into the downstream along the spillways on both sides. Now, the dam is completely finished. Next, they just needed to remove the temporary cofferdam for normal operation. For safety, workers first drilled holes in the cofferdam and embedded explosives. When the opening gradually became larger, they detonated the explosives to remove the cofferdam. Just like that, in 1936, the Hoover Dam was completed and began operation.